Okay, in this video I'm going to show you how to use the normal distribution Excel spreadsheet to find areas underneath distributions using the normal distribution CDF calculation you'll see over here on the left, as well as how we go backwards, which is if I give you an area shaded, can you tell me what the value is below? So the first ones we're going to do is the normal distribution. You can see we have a normal distribution with a mean of 0 and standard deviation of 1. This is the standard normal distribution. And what we're going to be asked to find is find the probability that, you can see right here it says x is greater than 1. So that means you can see we have the normal distribution, we drew the vertical bar at 1, and then we shaded to the right because those are the values that are greater than 1. So now what we need to do is to find this area, we're going to go to the normal distribution, and we need to choose left or right or in between. Well, you can see that this is shaded to the right, so we're going to select left or right. We want to pick a mean of 0, a standard deviation of 1, and that x value we were given was 1. And when I hit enter, what that does for me is you can see I'm given 2. This is the probability that x is less than 1. This is the probability that x is greater than 1. So that's the answer that I am looking for in this case. Would be 0.1587. All right. So the next one, you can see that this time I have a mean of 22 and a standard deviation of 0.56, and this is asking me to find the probability that x is less than 22.5. So again, I'm going to go to my normal distribution CDF. We're going to be working with left or right. I need to change my mean to 22. Oops. My mean to 22, my standard deviation to 0.5, and then my x value this time is 22.5. I just need to make sure I select the correct one. It's going to be this first one right here because this is the probability that x is less than 22.5. So my answer for this one is equal to 0.8413. All right, next one. Now you can see my mean is 5, my standard deviation is 0.5, and this is asking me to find the probability of x being between 4.5 and 5.5. You can see in the graph I've shaded between those two values. So this time I'm going to be selecting the in-between function. So it will be 4.5 and 5.5 with a mean of 5 and a standard deviation of 0.5. And now again, I'm just selecting the in-between. I know there's these inequality bars, but beneath it, it's the same thing. It's this is the probability that it's in between, and it's 0.6827. So that's how we do the in-between, left and right, when they are giving us the values underneath and we are shading the areas. The next problem says what IQ score separates, thank you, spell check, those with the highest 10% of IQs. So now we're going to be working with the inverse normal distribution. We can see right here that it's probably something right below 120. You could take a guess, but we want to know the actual value. So this time we're going to be working with the inverse normal because they are giving us percentages and they are asking us to find that IQ score. Again, I'm going to change, you can see my mean and standard deviation. My mean is 100 and standard deviation is 15, so I'm going to change those. And then I want to enter the area that's shaded. You can see that these are the top 10%, so I'm going to take 0.10. Now it's going to give me a range of values right here. And we need to make sure we select the correct one. Well, take a look at your picture. Is this a right tail, a left tail, or is it shaded in the middle, or is it shaded on the outside? You can see that this right here, this tail is on the right-hand side. So we are going to select a right tail. So the IQ score that separates the top 10% highest IQs would be 119. Let's just round it to 119. Again, you can kind of tell, I would have guessed it was 119 because it was right below 120, but it's not so easy to tell all of the time exactly. So this is why you have the inverse normal when you are given percentages and you need to find the exact value on this horizontal axis.